I'm Mattley, Senior Application Scientist at Ocean Optics, and we're here celebrating the International Year of Light by highlighting our customer applications. This year, we really want to put the focus on you and what you're doing with spectroscopy. We've got ways of showing how you're using spectroscopy on the land, in the air, in outer space, in the sea, and even on a process line in a diagnostic laboratory. Today, we're going to be looking at how you're using spectroscopy on the land. And the demonstration that we're showing is using the same components that we developed more than 20 years ago to make measurements in the ocean to help farmers with their agriculture applications. Now, these types of measurements are very important so that farmers can make sure that they're not using too much fertilizer, that they've got the right levels of moisture and organic material. And using the Ocean Optics components, they're able to make these measurements in the field. So we're now taking our measurement to the sample as opposed to having to take the samples to the measurement. So in our farm setup, you can see that we have a couple of different fields. We have a soybean field and a corn field. We have some fields that have cows and sheep in them. And we're using our NIR spectrometer, the NearQuest, to make quantitative measurements of the composition of these samples. You can see in our software, we're currently measuring the soil from our soybean field. So again, this is a measurement that you could do on a farm, or you could even potentially do the same type of measurement at a mining site or a drilling situation. So this is just one example of how you could do these types of measurements. So we've got our sample, and we are currently looking at the spectrum for our soil from our soybean field. We can see some spectral features here. We know this is related to water. But to really get quantitative information from the spectrum, to really help the farmer determine what he needs to do to his fields to improve his yields and avoid waste, we had to do some chemometrics modeling. We had to do some quantitative analysis. And so what we're showing here is the actual values that we're able to get from this spectral data. So by eye, we can see some differences, but to really get the numbers, we have to use a calibration model. So what we can see is, using this model, we're able to look at the moisture, urea, and organic content, very important parameters for the farmer so that he can help with his yields and also to reduce his waste. We are very excited to be showing our Rotocup sampling accessory. This is very important anytime you're making measurements of real-world samples, which, let's face it, are never homogeneous. We've always got some heterogeneity, and representative sampling is critical. By using this setup, we actually have a DR, our diffuse reflection probe, which has a light source built in, and we use our rotating cup accessory to make sure that we're making several measurements around the sample. This is going to improve the accuracy of our measurements and help us take into account the fact that this sample is not the same in every location. Thank you for spending some time with us today to see the specific application we're doing in precision agriculture. We really are looking forward to celebrating the International Year of Light this year by highlighting your applications and what you're doing with spectroscopy. For more information on this application and many others, please visit us online at oceanoptics.com.